Hello. Well, I've been trying to dot the I's and cross the T's and get the electronics and the software into a state where I can actually run a test on the boat on a lake. It's surprising how many little things you have to do to get the thing sorted. But I think I'm nearly there now, so I'll just show you where I've got to. Well, I was quite surprised how quickly this thing stopped working when it got wet. So I decided to put this silicone conformal coating on it. You have to put it in an oven at 90 degrees C for 2 hours to finish it off. At least it'll stop the copper corroding. No sooner had I done that than I decided I wanted to add something to the circuit, so that was a bit of a nuisance. What I've done is I've wired up the SD card writer so that all the logging goes to the SD card as well as going to the telemetry. So I've got a single serial line coming out of the autopilot which carries the logging information, and it goes to the telemetry and to an SD card. I knew that the LoRa radio link would not take all the logging data that I'm supplying it with, but I had assumed that if you just squirt data at this LoRa transceiver at a faster rate than it can accept, that it would just throw the data away. But that's actually not what happens. What happens is it just stops transmitting entirely. So that was a bit of a nuisance. So what I've done is put a FET switch in the circuit to the telemetry so that the autopilot can just interrupt the data going to the LoRa radio whenever that radio is busy. So it's using the clear to send signal just to turn off the telemetry when it would otherwise get confused. So the result of that is I've got a full record of the autopilot log on the SD card, and as much of that log as I can push through the LoRa telemetry goes via the radio link to a laptop shoreside. But in order to do that I had to put this FET switch on the card, so I had to get my penknife out and scrape off the beautiful conformal coating that I'd just put on in order to do that. Last time I discovered that the LoRa radio was only transmitting about one line of the log every 2.2 seconds, and that was much too slow. After fiddling around with the buffering and the way I send the data to the telemetry, I decided that the only solution to this was to change the LoRa parameters. So what I had before was an RF factor of 2048 and an RF bandwidth of 125 kilohertz, I think that is, giving a data rate of 537 bits per second. And I've changed this to an RF factor of 1024, a bandwidth of 500, giving a data rate 7 times faster at 3908 bits per second. But the consequence is that the sensitivity loses 9 dBm, goes down from -135 to -126 dBm. That will obviously make the range shorter, and I don't know by how much this is going to affect it, but we'll just have to put up with it and try it with this these new settings. With these settings, the telemetry can almost keep pace with the 9600 baud logging output from the autopilot. So here we've got on the left what's being transmitted, and on the right what's being received by the LoRa receiver. As you can see, the data is coming across pretty much without a delay. When we get a long line, that's a GPS report. It doesn't always occur in exactly the same order on the telemetry receiver as it was transmitted, but that is an artifact of the way I control that FET switch. But basically the telemetry is now keeping pace with the log coming from the autopilot. So here we've got the autopilot box in its proper configuration and plugged in to the radio control unit and plugged into the rudder and plugged in to the LoRa transmitter, and the LoRa receiver is over there as usual, and then that's coming back, and we've got the autopilot visualization here. So what we've got here is the same visualization you've seen before, except that now we have a mission on the map with a start point and an end point and two waypoints marked P1 and P2. And in the bottom left corner of this screen, the salmon coloured box is new. It shows what the autopilot is doing. We have a very simple autopilot which simply calculates the course from where the boat is to the next waypoint. It doesn't have any tacking logic, it doesn't have any cross-track error correction. I thought we'd start very simply. So the autopilot then, having calculated that course, gives it to the helmsman, which is in the pink box directly above, and the helmsman then steers an appropriate course. The GPS information that you see there is simulated, because I'm not actually sitting on this lake at the moment, but I intend to sail this mission as soon as we can. So that's where I am at the moment. One worrying thing about this is that when I set the stuff up this evening, to start off with, everything was working except the LoRa telemetry connection, and I put a scope on it and saw that the serial data was actually going into the LoRa transmitter, but it didn't seem to be transmitting anything. I fiddled about for quite a lot, and eventually it suddenly started working. Now that's exactly the kind of unreliability I don't want. Everything else, all the Arduinos and open logs and micromites in this electronics is solid, but these LoRa boards seem to be not working as reliably as I would like, although it may be entirely my fault. It may be that I have got a loose connection somewhere or a temporary short circuit or something, but it's something that I've got to try and get a grip on, because we can't have any kind of unreliability of that kind, or any other kind for that matter. Anyway, thanks for watching.